All right, everyone. Welcome to Simplilearn webinar on auto scaling with AWS. My name is Raj, and this is going to be an exciting tour about auto scaling with Amazon Web Services. I'm an AWS certified solution architect, and I have a lot of experience in cloud and other technologies. So today we're going to cover a lot about auto scaling, and so let's not waste any more time. Let's crack on with this. So today's objectives, we're going to introduce about EC2, just a little bit of introduction on EC2, and then we're going to go in depth on auto scaling. We're going to look into the different types of scaling, how have the traditional IT that has been, and then we're going to look into auto scaling. Then we're going to go deeper into auto scaling. We're going to look into auto scaling terminology, which are launch configuration, auto scaling groups, scaling policies, after which we're going to have a demo, and finally we'll have Q&A in the end. Right, so let's go on. So the important thing about auto scaling is the fundamental component and this fundamental service that Amazon offers, which is nothing but Amazon EC2. EC2 is Elastic Compute Cloud. This is a service that offers resizable compute capacity in Amazon Web Services. So you'd have servers ready on Amazon. So this is where EC2 plays an important role for almost all major components that Amazon's portfolio has. So it's flexible. You could run Windows or Linux distributions. If you're familiar, Amazon EC2 instances previously, so you know that you could run a Windows or a Linux-based operating system. So it's scalable, so it has a wide range of instances from micro to cluster compute. So it's like one CPU, one VRAM to 1 GB of VRAM to all the way up to like 8 and 32 gig, 8 vCPU and 32 and more. So you'd have these clusters available, and these are the options that you'd get. We definitely have a brief look into those when we are building our launch configuration. So remember that we're going to look into the scalability factor over there. Then you have the machine image. So machine image is nothing but a snapshot of an instance which has an application bundle with it. It need not be with the definition I just provided. It could also be like you have a distribution, a Linux distribution that's there, and you want to build it. So machine image is actually a configuration from which new instances can be created, right? So then with EC2 you also get full root and administrative access. There's no restrictions. You could do whatever you want with your own server. You are the admin of that server. You have full control on that. So again, the next is security. So those EC2 instances are secured using firewall, which is the security groups. Then these EC2 instances are pushing a lot of information to CloudWatch, which is the monitoring service of Amazon. So you'd want to monitor a couple of services that's there. You want to monitor the CPU, memory, the network usage. If you have a load balance, you want to see how the performance of that is. So you'd use CloudWatch to monitor that. So you wouldn't need a third-party tool that could monitor that. So, and basically, you know, EC2 is inexpensive. So there are 3 different variants of EC2. That's on demand, which builds up and powers on VMs whenever you want. Reserved is something that you would book it for a longer period of time, and you have highest cost saving there. Spot instances are nothing but that fluctuates on price. So you would want to purchase a large set of servers together, and probably you are running a massive big data analytics, and you cannot afford to spend money on compute instances. So that's where you would use your spot instance. And finally, you have the VM import export. So if you want to transfer configuration in and out of EC2. So these are the features that EC2 offers. So do want to give you a brief introduction on EC2. EC2 is an elaborate topic altogether, but this one page should give you an idea about what EC2 is and how we're going to use it. So we're going to use EC2 in setting our auto scaling. So going back, what are the vertical and horizontal scaling types that's there? So what do you mean by vertical scale is that you want to increase the existing instance. So in your terms, if you have a desktop or a server, you are increasing the memory of that from 4 gig to 8 gig. So within that scope, so that's basically vertical scaling. Horizontal scaling is you add additional instances. So you add and remove additional instances. So you have one server, you add a couple of them more. So that's horizontal scaling. You would want to choose between them depending on your application and your demand. So that's vertical and horizontal scaling. And going back how this traditional IT capacity usage pattern has been, so this was the on and off pattern, wherein this blue line is how you're responding, how the demand is, and the gray line on top, your capacity, your current capacity. So the first is on and off. So you have a demand for some period of time, and you already have built the gray line, which is your baseline capacity. So you probably purchased a lot of servers anticipating you have demand coming up. So you have the gray line, which is the amount of capacity that's there, and the blue line is where your actual usage is. So on and off is where you have a demand and sometimes you don't have. So that's phases. That's the phase over there. But fast growth is the second one, where you're growing a business and there's a lot of things coming up. You need to install more and more servers, and at the same time you need to deliver this as well. There's rapid usage going on. So that's the linear way of growing. So then there is variable peak. This is where you have no idea what's going on, and even if you have an idea that, okay, I have a lot of business coming in, these are the applications, this department needs capacity, and you're trying to plan it, but sometimes you don't plan it well, and there's a lot of underutilized hardware there, and then at some point you're unable to meet the demand itself. So that's this peak wherein you're not able to meet the demand that's available, that's made. So you don't meet that. So that's a variable peak that's there. And then there is predictable peaks. So you predict and you install a lot of hardware inside your data center or anywhere else, and you don't utilize it at all. So it's basically you wasting resources. So what happens? So this is what happens. You have a lot of wastage of resources in capacity. So you're not utilizing a lot of hardware on one hand. On the other hand, when you're unable to deliver any capacity request, the demand that is coming in, you're unable to provision server, you're unable to provision storage, you're basically losing your clients, or you're having performance issues, or you're having outages. So the poor service and wastage of resources, those are one of the key concerns, and this is solved by cloud computing. So cloud computing guarantees elasticity. Elasticity ensures that you could scale up and scale down as and when needed, right? So this has been the traditional pattern. So I'm going to show you a quick sneak peek on how auto scaling works. This is just to give you an idea how this would work, but we're going to go in detail, but this is how it is. So you have an EC2 instance, which is a group of servers, and you call that as an auto scaling group, which pushes the data to CloudWatch, which is a monitoring service. So CloudWatch is actually monitoring, is watching the EC2 service, and it's going to see whether something, and I'll say something because something could be a CPU or a disk usage or network usage. So it's actually watching what's going on with this server. Is it having high usage? Yes. Okay. It's going to trigger some alarms. And then what it's going to do is it's going to find out what is the scaling policy that it says. Okay, if I have, so scaling policy is nothing but a flow chart or a step by step. It says, okay, if I have CPU usage more than 50%, what should I do? I should add another instance. So scaling policies is going to do is, okay, let me try to find out an EC2 instance, find out the launch configuration. Let me try to bring it up. So it brings it up, and then it adds to the auto scaling group. So you're expanding your capacity, your infrastructure automatically. Yeah, automatically. So you don't have a lot of manual work. Actually, you don't have any manual work. So in the demo we're going to demonstrate after this, you would see that we're going to have a web page, because I'm not building a website for now. I'm having a web page. I'll make sure that's always available and how the instance are there. So this is a small sneak peek. So let's go in detail. So basically it's automatic resizing of compute clusters based on demand, right? So we define the maximum and minimum preferred instances. So we're going to define that this is the amount of instances. You could imagine, you need to imagine this is what my application is. My application needs at least 2 servers at all times, and if I need to add more, I need to add 2 more on both the availability zone. Availability zone is nothing but a data center. You could relate that to be a data center in one region. So then you define, as you saw in the previous slide, so when would you scale out and scale in? So when, at what point, is it high CPU usage you would want to scale out, or you have a lot of incoming traffic coming from users trying to buy something, so you won't want to add additional instances based on network usage, and then these metrics are collected by CloudWatch, and then it pushes these scaling instructions, right? So then you would run the auto scaling. It pushes these auto scaling instructions. Hey, let's power on more servers. We have a huge demand coming up, right? And finally, this is important. Auto scaling, this whole function is free. This whole using the service is absolutely free, but you only have to pay for the resources that's used. So when you power on that EC2 instance, you'd have to pay for it. You'd have to pay for the usage and whatever that would turn out to be. This is quite nominal in my opinion. You're not paying anything for the service, auto scaling service. You're just paying for the functionality. When I say functionality, it's the services. You're just paying for the instances only, right? So imagine this is your auto scaling group, and you have 2 instances, and this is pushing the usage and metrics to CloudWatch. So CloudWatch is gathering this information, and it's having a literal watch on all the instances, and it finds something abnormal. When I say abnormal, high CPU usage or high network usage, you would have to define it, and it would send scaling instructions and say, okay, my CPU is high, I need to add 1 EC2 instance. Then after some time you find out, oh no, I have further web traffic coming in, my workloads on these instances are unable to handle them, looks like I need to add more. So it would add more automatically. Until when? So until you define on the maximum limit, the second bullet point over here. So you have to define at what point you are okay to survive economically, because if you put this to infinity, you'd have hundreds and thousands of servers booting up, and that means you need to pay for all the usage that's happening, right? On the other hand, you could, this is one way, using CloudWatch. So then you'd have queues and metrics using the simple queue service of Amazon, if it's based on a queue, and these queue would trigger that based on certain actions, CloudWatch would monitor that, and based on certain queues that have been defined, it's going to push scaling instructions to do something like add or delete an EC2 instance, right? So that is also the other way of expanding on auto scaling. Further, if you find out it's the night time, you don't have any users coming in, and probably you don't want to, the usage has come down automatically, it's like close to 10%, probably because it's night, or probably they are in a different time zone. It would send further usage and metrics information to CloudWatch, and CloudWatch would monitor that and send scaling instructions to delete or remove the EC2 instance. So EC2 instances would get terminated, right? So this is how auto scaling would respond. So the red line that you see is how auto scaling responds to current and desired capacity. So it would go in line so that you don't suffer A, outages or performance issues, or B, availability. So you have never that problem. And finally, and the most important thing, you're not investing any hardware in advance. So you would just bring out new instances when there's a demand. So that's how the auto scaling works here. So some of the terms that you need to know for auto scaling are auto scaling groups, launch configurations. Don't worry, we're going to look into all these in details. Scaling plans, the way in which you should scale. Alarm, the CloudWatch alarm, what it pushes. ELB, or elastic load balancer, which is on top of these instances. Probably if you're having a web front end, if you have a website. In our example, we're going to use an ELB. We're going to have EC2 instances below the ELB so that you'd have a single C name to connect to your website. And then instant metadata and user data. So this user data is the configuration scripts that you send to your EC2 instances when they boot up, so that you have a predefined configuration. So you need to automate everything. So let's get into this a bit closer. So auto-scaling group is a group of EC2 instances. They're categorized based on similarity, right? So you create auto-scaling group by defining the minimum, maximum, and optionally the desired number of running instances. So this is what you would define the group would be. Then launch configuration is the auto-scaling group is going to use the launch configuration to launch EC2 instances. So this launch configuration, imagine this to be a template that these are the type of servers that I want to power on. So it could be an Apache server or a Windows server, and this is what I have defined it to be. Right. Scaling plan, as I said, tells when and how to auto scale. So at what point should I auto scale, and when I see that, what should I actually do? Right. So that's the scaling plan. We're going to look into this much closer now. So an auto scaling group contains a collection of EC2 instances that share similar characteristics and are treated as a logical grouping for the purpose of instance scaling and management. For example, if a single application operates across multiple instances, you might want to increase the number of instances in that group to improve the performance of the application, or decrease the number of instances to reduce costs when the demand is low. So you can use the auto-scaling group to scale the number of instances automatically based on the criteria that you specify, or maintain a fixed number of instances even if an instance becomes unhealthy. Right. So you need to keep a minimum number of instances running, and you launch or terminate instances to meet the desired capacity, right? And then you ideally never start more than the maximum number of instances. No, as I said earlier, you don't want to pay too much, right? And then balance this across availability zones. Availability zones, spread them across different availability zones so that you don't run into any of these capacity issues or an availability zone going down issues that might happen. So launch configuration, you would determine what is going to be launched. So as I said, launch configuration is a template that an auto-scaling group uses to launch EC2 instance. So when you create a launch configuration, you specify information of the instances such as the ID of Amazon machine image, the instance type, the key pair, or the security groups, which is a firewall, and a device mapping. So if you have launched an EC2 instance before, you specify the same information in order to launch the instance. So when you create an auto-scaling group, you must specify launch configuration. So you can specify launch configuration with multiple auto-scaling groups. However, you can only specify one launch configuration for auto-scaling group at a time, right? And you can't modify a launch configuration after you have created. So therefore, you want to change launch configuration for your auto-scaling group, you must create a launch configuration and then update your auto-scaling group with the new launch configuration. So when you change the launch configuration for your auto-scaling group, any new instances that are launched using the new configuration parameters, but existing instances are not affected. So you would use this if you want to have existing launch configuration and you want to build out a new set of them, because you probably upgraded all the instances to a newer version. So you would slowly push them off and have the new ones take over. It's basically the EC2 instances and the type and size that's there, then the Amazon machine image, the security groups, keys and stuff. So basically it tells you the template. So what is scaling plans? So scaling policy is a set of instructions for making such adjustments. What's going on, just adjust it. So you always have to focus on scaling plans, in fact, and of course everything is important, but scaling plans affects your cost a lot. So when does it scale in and scale out? So if desired capacity is greater than current capacity, go ahead, launch instances. If desired capacity is less than current capacity, please terminate instances. You don't want them running, right? So that's how the scaling plans are. Then, so a couple of important things. So ensure your current capacity of healthy instances remain within a limit. So never less than minimum, right? You don't want to have one instance running and keep them probably on two availability zones, or if make it 3 if you have 3 availability zones in your region. So manual scaling is when you modify yourself. You don't want to do that, but yeah, it's possible. You can add an instance if you feel like you want to do it. And this is not a predefined one. So you log in to auto scaling and say, okay, I have 2 now, let me make 3. Probably I know that we would have a demand. Then there's scheduled scaling plans. So wherein you know that during the day you need 4 or 5 servers because there's huge demand and there's a lot of users logging in, but you know that after say 9 p.m. and all the way till 6 a.m. in the morning, none of the users log in. So you'd want to cut it down between 9 to 6 a.m. So these are scheduled instances, scheduled scaling plans that you could also try. And finally, the most important thing is dynamic scaling. This is what you should be ideally using so that you save cost and ensure availability at all times. So that's based on CloudWatch metrics. So it's going to watch the metrics and you define, you do those actions based on certain data. All right. So I'm going to give you an introduction to step scaling. So you always want to think that CPU usage goes high, let me increase it, but what happens next? So let's take an example here. So on the first one, there's the first star, red star that you see here. This is, so you have defined your CPU utilization to trigger an alarm when it reaches 60%. So you have defined that. So CloudWatch actually notes that. It's gonna note that, but it's not gonna take any action. And it's gonna wait a period to ensure that this alarm is actually real. It's not like it was just a peak and it didn't go down. So after an evaluation period where it feels it's going to do another check and it finds out, hey, it's still above 60%. So at that point of time, it's going to take a scaling plan. So that's when the alarm triggers and then a scale out action comes in. Scale out action is nothing but, okay, the usage has gone up, so let's take an action. So it's going to take an action to bring out a new instance or 1 or 2 instances based on what you have defined. So where like you have defined that if the alarm usage is above 60%, make sure you add 1 instance. So that happens at this point of time. So and the instance comes up, after which you have a cool down period. So cool down period is when it's going to make sure that no other because this server just came up live. So it's going to make sure, it wants to make sure that there is no other instances accidentally being powered on, because there was an alarm trigger at an early point of time at 60 and there was a response at 70. So we don't want to accidentally add more instances. What this also means is that between that period, there won't be any additional alarms, right? Isn't that a risk? Yes, that could be a risk. The reason is, have a look at this. So imagine you have your alarm at 60%, and then, you know, as I said earlier, you want to actually monitor. Is it really 60% or not? Is it really 60%? You're going to check back later after redefine. So in my graph, you could see that it's 1 minute interval. So it's going to see that, okay, let me wait for 1 minute and see how the utilization is. But in that 1 minute, what if the CPU utilization or any other metric utilization went over the roof? So it went all the way to 90 and 100, and you have very bad situation. So that's a difficult, that's not an ideal situation to be at. The reason is, so you were too late to respond to your event, and probably your application or your website went down in the meanwhile. So there's something called step scaling. So step scaling defines multiple steps in the same policy. So it's going to take out the appropriate scaling, and it's based on a value, and it triggers thereon, right? So step scaling are continuously evaluated, and there's not like, okay, don't do this, wait for some time, and then find a next action. So, and there is no locking. The alarms are kept continuously evaluated even when the EC2 instance is being scaled, right? So we have an improvised version in this graph. So you get different alarms being triggered, and then there is granular level, and then you're going to take action thereon. So this is, I'm going to show you a small screenshot how it is done. So you take an action at 0 instances between 0 to 50. I don't want to take anything, that's there. but I'm going to add 2 instances when it's between 50 and 70, and I'm going to add 4 instances when it's something after 70%. So this is what you're going to do. This is a screenshot of how you would do step scaling. Right, then there is termination policies. So that's where you define when you want to terminate. So you want to terminate the longest running instance first. Probably it's ideal when, the termination policy, I want to tell you that this is when you're scaling down. This is when the CPU utilization, everything fell below, say 5% or even 10%. And there's a lot of instances, so you could actually get rid of them and save costs. Your scaling policy should know which one should it terminate. So that's where this policy is important. So it's going to terminate the longest running instance because you'd have memory leaks and different sort of problems on the longest running instance. So you'd get rid of the oldest server, then the oldest launch configuration. So you have a launch configuration, multiple configurations, multiple launch configurations. So you'd use them. You would get rid of the oldest launch configuration, and then the next is which is closest to the full billing hour, the billing cycle basically. But important thing is it's going to ensure that rebalancing of capacity across availability zones that takes more precedence than the above ones. So that's the most important thing. An intro on CloudWatch. CloudWatch is a web service that enables you to monitor and manage various metrics. So it's not just limited to the CPU, network and others. So there's a lot of metrics that you could monitor, and you could use this to define your scaling policies. So an alarm is an object that monitors the scaling metric. So the metric could be network usage, disk usage, CPU usage. So the alarm changes its state when the value of the metric reaches a defined range and maintains the change for a specified number of periods. Next, we're going to talk about load balancing, right? ELB. So ELB is something we're going to put on top of your instances. You can see that on the figure on the right-hand side. So it automatically distributes incoming application traffic across multiple Amazon EC2 instances. Application will have a single point of entry, right? So you won't enter the EC2 instance web page, but enter the ELB CNAME. So it's not an. So I'm going to show you the CNAME that I have in the ELB, right? So then you would use your ELB metrics to scale your applications. So and then there's connection draining. So to ensure that, say an application and as auto scaling is planning to terminate an instance, so it's going to wait for all the requests being pushed to the EC2 before it even thinks about terminating due to a scale down request. Okay, so what's the benefit of auto scaling? It automatically adapts to capacity on demand. We have seen that in the graph. It's going to grow and shrink based on the demand. So we achieve that. We achieve elasticity, key thing. Next, it's not just elasticity, right? When you define a minimum number of instances, what are you saying? You're saying that these are the instances that needs to be available at all time. In our example, I'll try killing few instances. I'll try to destroy my EC2 instances. But you know what the auto scaling is going to do? It's going to automatically power on more and more, not more and more, more instances to ensure it's available at all times. So you have availability as well. I want to talk about bootstrapping here. Now, remember that you're building an auto scaling group. You need to do this when you're sleeping in the night. You don't want to log in, wake up, and add more instances. This was a traditional way. If you want to do something where you can comfortably go to bed without having to log in and build up some build new servers or add storage, auto scaling have to be fully automated. So automation comes through various ways. So you could use an Amazon machine image, which is a snapshot of your current application example. In this example, it's going to be a web server. So if you could take a snapshot of that and make a custom Amazon machine image, you could ask your launch configuration to use your specific AMI and build up new configuration. So that way, you don't have to configure your server each time you build it up. So that's why bootstrapping is quite important. Then you could change it to base EMI and install a code and configuration as needed, as when you need it. So you use that via user data, or you could use it via Chef, Puppet, Ansible, You could also use it by AWS code deploy. So that would be pushing out these install code and configuration. Right. So in our example, we will add the following script. And this is a script I've wrote. So what it's going to do? So it's going to install HTTPD. That is, I mean, basically this is an Amazon machine Linux. And what I'm planning to show you is I'm going to show you the HTML page, a simple HTML page. But the key thing is I'm not going to log into the server and do anything. I'm not going to log in or install Apache or copy and configure these files. I want to do everything automatically. So the first thing is the shebang, as you must know. Then I'm going to install Apache, and then I'm going to update my server. So that's the second command. Yum, okay, correction there, yum update -y. Then I'm going to use a S3 Amazon command. So this is Amazon's Linux, and I need to have a CLI installed. So this is a CLI command if you're not familiar with. So AWS S3 CP. CP is copy. Copy. This is a bucket. This is an S3 bucket where it's stored. This is where I've stored my file. So you would want to create an S3. You would want to create an S3 bucket and store them. And I would copy that file to the var www HTML file. The index gets copied there. Then I'm going to copy a health check file as well to that. This is going. The health check file is needed for the elastic load balancer to check the page to ensure that the instance is indeed running. Then last, I have a command that starts the Apache service. So this is the command that I've already written. And finally, but this is probably not necessary, I'm going to add the service to the boot, right? So this is a snapshot of what we're going to do, right? So why do we auto scale? So, and why do we bootstrap? Basically, because less fingers, less mistakes. So once we have a tested script and deployed it, there won't be any errors, right? Because it's all, you do regressive testing on these and make sure you don't have any human being coming and logging in. You don't need that. So that's an important thing. So you have self-healing option available using this. Then you have efficiency. You can easily audit and manage your state. So if something goes wrong, you can actually come back and see what's my bootstrapping script says. So how is it going? What is my shell script that I have actually written that has told how to manage this? Then you could scale on a large scale deployment. So in fact, to give you an example real time, a lot of people use auto scaling every day, millions of customers of AWS, and I can guarantee that a lot of auto scaling is happening right now. And how do they use? They would actually could have an on-premise infrastructure somewhere for their web applications, and they would even do something like, in case my existing servers in my data center is running out of capacity, I would use Amazon services and build up new servers. So this is what the automation comes into play, right? And then it's flexible. The bootstrapping is not just limited to shell. You could use PowerShell, pardon this typo there, CloudFormation, Chef, Puppet, Opsworks. Opsworks is the Chef applicable in AWS. Finally, security. You are locking down your instances, so no one else can log in. And you actually, some of the reasons where this is there, you don't even have to log into the server, and you probably disable all type of logging, right? So that's about it. So how are you going to plan your auto scaling group? So you determine the time it takes to launch and configure the server, right? Because if it takes a lot of time to configure, launch and configure, probably your web traffic is still busy, right? And you want to match and plan accordingly. So, and the most important thing, you need to find out what metric is the most relevant to your application demand, right? So you cannot, and I'm showing CPU usage, but that is not always the case. Web traffic, maybe network, and maybe CPU as well. So you won't want to monitor one or two or one metric or more, right? But you need to know what is driving your application's performance. So you need to know what metric is the most relevant thing. Right, next is what existing EC2 instance or AMIs you might want to use as part of your scaling plans, right? So you want to know what should I use. Should I use a Windows one or which AMI should I use? So that's something you need to plan. And then how many AZs that you want to spread all these auto-scaling group. And then the role you want to play for the auto-scaling group for your application. Remember, I've been talking about web, but you could have web, your database, your application, all in an auto-scaling group, and then you would want to know what kind of role should each play in their own perspective, right? You have web, DB, and application. You want to know how should you manage. So these are things you should think about. All right, some do's and don'ts. You need to use IAM roles. IAM roles are nothing but identity access management. That's a full form. So what it tells EC2 is, this is the EC2 instance that must communicate with S3. In my example, remember there was an AWS S3 command. To run that command, I must give the privilege to EC2 to set up a relationship, basically, to read the data from S3. S3 is another service. So that relationship is built by an IAM role. So that role, that relationship should exist. And go keyless if you can. Keyless is where key pairs, if you have ever built an EC2 instance, you know that to log into it, you need a key. So ideally, and if you build an auto-scaling group, you should go keyless so that if even if someone has a key, they won't be able to log in because the key was not defined for those particular auto-scaling. Then you need to strike a balance between your golden image, which is your AMI, and bootstrapping. So probably you have a set of servers that's there, and you have built your application already. So probably what you could do is you take an image of that server, the existing server, which has the application, and then in your bootstrapping script. So when it boots up, it could probably do an upgrade, an update on the system, right? Okay, then some don'ts. Don't put your access keys anywhere in your API, anywhere. Do not put any of those keys in your AMI or even your bootstrapping scripts. Right, a lot of talking. Let's get on to the demo. Right, so, okay, and that's it, everyone. Thank you, everyone, for joining Simply Learn webinar. Take care. Bye-bye.